Not long ago, an amateur astronomer spotted an unusually bright object in the data collected by the SOHO solar probe. This mysterious light turned out to be a previously unknown comet, now officially named C/2025 F2, Swan. Both professional astronomers and skywatching enthusiasts were excited by the discovery, hoping the icy wanderer would light up our skies in a dazzling display visible to the naked eye. However, recent updates have brought some disappointing news about Swan. So, what exactly happened to this comet? In today's video, we'll uncover how this celestial visitor was discovered, explore why comets are such valuable keys to understanding the universe, and reveal the surprising fate that awaited Swan. For thousands of years, comets have captivated, and sometimes terrified, humans. In ancient times, their sudden appearance in the sky was often seen as a bad omen. Even Aristotle once suggested that comets were swamp vapors rising into the heavens, an interpretation that only fueled fear and superstition. And for many centuries after, these glowing intruders were still viewed as cosmic messengers of misfortune. Comets have long been feared as omens of disaster, blamed for toppling kings, collapsing empires, and triggering famines and plagues. And this fear wasn't confined to ancient times. Even in the modern era of telescopes and scientific progress, comets inspired panic and exploitation. In 1910, during the approach of Halley's Comet, unscrupulous entrepreneurs profited by selling bogus remedies for comet fever, which was supposedly caused by the comet's toxic gas tail. The anxiety surrounding comets reached an even more tragic peak in 1997 with the appearance of the Hale-Bopp comet. The Heaven's Gate cult believed the comet was a spacecraft destined to carry them to a higher existence. Tragically, 39 members took their own lives in a mass suicide, convinced this was the only way to join it. Fortunately, such dark associations have faded. Today, comets are understood through the lens of science as small celestial objects within our solar system, recognized for their distinctive glow and unique chemical makeup. Although comets may look similar to asteroids due to their rocky appearance and comparable sizes, ranging up to a few dozen kilometers, they are primarily composed of water ice, dust, and frozen gases. Unlike asteroids, which tend to orbit closer to the Sun, comets are mostly found in the outer reaches of the solar system, gathering in large numbers in regions like the Kuiper Belt and the distant Oort cloud. These icy bodies travel along highly elliptical orbits, which keep them moving slowly and far from the Sun for most of their journey. But when they swing into the inner solar system, they pass close to the Sun at great speed for a brief period. While they remain in the outer regions, near the giant planets or beyond, their dark, non-reflective surfaces make them some of the dimmest objects in the solar system. However, this changes dramatically when they approach the inner planets, as sunlight begins to transform their appearance. As a comet approaches the Sun, its heat causes trapped gases within the comet to vaporize, forming a diffuse cloud of gas and dust around the nucleus known as the coma. This process also gives the comet its most iconic feature, the tail. As solar wind pushes against the coma, it creates a tail that always points away from the Sun. This tail can stretch for millions of kilometers and glows brightly as it reflects sunlight, making comets a stunning sight in the night sky. But comets aren't just visually spectacular, they're also of immense scientific interest. Take the discovery of Swan, for example. Comets are among the oldest, most pristine objects in our solar system. Dating back about 4.5 billion years, they are thought to be remnants from the time our solar system first formed from a massive disk of dust and gas. In essence, they are time capsules, tangible relics of the very earliest material that shaped our cosmic neighborhood. But that's not the whole story. Some scientists suggest that comets may have played a crucial role in transforming Earth into the water-abundant, life-supporting planet we know today. There's already evidence indicating that the water in Earth's early oceans, and possibly even the basic ingredients for life, might have arrived from space. With that in mind, studying comets clearly holds significant value. But that raises an important question: how do we actually find these icy wanderers? Typically, comets are spotted by professional sky surveys using automated systems that scan the heavens for moving objects. Still, amateur astronomers have also made impressive discoveries. In fact, in 2023, a Japanese hobbyist stumbled upon Comet Nishimura while reviewing photos taken with his regular SLR camera. Comet C/2025 F2 Swan wasn't discovered by a professional astronomer, but rather by Australian amateur Michael Madiazzo. In late March, he identified the comet while analyzing publicly available data from the Solar and Heliospheric Observatory, SOHO. To be thorough, it's worth noting that two other independent observers, Vladimir Bazugli and Rob Matson, also spotted the unknown object around the same time. Interestingly, SOHO wasn't designed to hunt for comets. Jointly operated by ESA and NASA, the spacecraft has been monitoring the Sun for nearly 3 decades. However, its Solar Wind Anisotropies (SWAN) instrument, which captures ultraviolet images, can also detect comets. When sunlight causes the ice on a comet's surface to sublimate, it releases ionized hydrogen. This hydrogen emits ultraviolet light, which SWAN registers as a glowing point in its field of view. On March 29, a bright point of light moving steadily across a series of exposures caught the attention of Michael Madiazzo and Simon Bazugli. Just 2 days later, Robert Matson officially reported the discovery. However, initial confirmation from authorities was slow. As Madiazzo noted, "I couldn't verify the comet because it wasn't visible from my location." Fortunately, the comet hunting community is both tight-knit and highly resourceful. As word of the discovery spread among amateur astronomers, it wasn't long before the first ground-based images of the object surfaced. Further analysis of archived observatory data revealed that this comet, now dubbed Swan, had actually been in view for quite some time. Images from Xingming Pan-STARRS and the Cerro Tololo Inter-American Observatory showed it had already been visible as early as September 2024. This fleeting cosmic visitor stirred memories of comet lore. Over 300 years ago, Edmund Halley, the man behind Halley's Comet, suggested that a celestial object might have even made its way into the Bible. He believed the Star of Bethlehem was, in fact, a comet. While modern science has disproven that theory, the allure of comets endures, especially those rare ones officially deemed great comets. Unfortunately, Swan's moment in the spotlight was brief. There isn't a universally agreed-upon definition for what exactly qualifies a celestial object as a comet. However, a practical guideline is that a comet is considered notable when it becomes visible to even casual observers in the night sky. For this to happen, the comet needs to reach an apparent brightness comparable to the 22 brightest stars, around a magnitude of 1.5. This category includes famous visitors like Halley's Comet, which has appeared approximately every 74 to 79 years since 240 BC. More recently, the comet Ikiyaseki captured attention in October 1965 when it split into 2 pieces and became the brightest comet of the 20th century, shining at an impressive magnitude of -10. Hale-Bopp, which was briefly mentioned earlier, holds the distinction of being the most observed and photographed comet of the 20th century. With its 2 striking tails, it remained visible to the naked eye for a remarkable 18 months, longer than any other comet on record. So, what about the Comet Swan? Could this icy visitor put on a similarly stunning display in our skies? Unfortunately, it doesn't seem likely, but let's explore the details step by step. When first discovered, Swan appeared as a faint, greenish point of light in the early morning sky, just before sunrise. Although Swan wasn't visible to the naked eye, it could be seen clearly with binoculars or a small telescope. Using the right equipment, observers could make out the comet's greenish gas envelope and faint tail shining in the constellation Pegasus.